Imagine your data, AI data to be exact. Data comprised of billions of pulses of light that travel over and across the internet, carrying information derived from intelligence that is critical to your business. If your business relies on real-time data delivery arriving at a second's notice without quick crash or system failure, Supermicro is the clear choice, delivering extreme performance with petascale all-flash NVMe storage to support proven architectures for AI and ML workloads with leading software-defined storage platforms. If you're an enterprise business, government agency, or in the education and research sector building a public cloud, private cloud, or generative AI supercluster, there's only one choice. And that choice can only be exactly the best.
Hello and welcome to this session of the Supermicro Open Storage Summit on scaling up or scaling out, making the right storage architecture decision. I'm Rob Strechay, Managing Director with theCUBE Research and your moderator for this special session. Scale out and scale up storage play distinct roles in addressing the needs of modern IT environments, particularly when it comes to handling large volumes of data and ensuring high performance. Scale-out storage involves adding more nodes to a system, allowing for horizontal expansion. This approach is beneficial for organizations that need to handle increasing amounts of data without disrupting existing workflows. Scale-out storage systems are designed to provide linear scalability in both capacity and performance. They allow businesses to start small and grow incrementally, which is particularly useful for adapting to evolving data requirements. Advancements in tiering automatically move records between storage tiers based on access patterns. This automation reduces operational complexity and ensures cost savings without compromising accessibility when needed. One common thread in some SDS systems or software-defined systems is the use of offload engines in CPUs. This separation of duties not only enhances the overall system performance, but also increases security by isolating sensitive operations from the main processing unit. Now, before we jump into the discussion, I'd like to just let you know how things are going to roll today. All of the materials from the partners that are up here on stage, and we have a few of them, all that material is going to be at that registration link on the website, thecube.net. And the speakers will be live on X to take your questions. Use the hashtag SupermicroStorage 2024, and that's all one word, to ask your questions. Now, let me introduce our speakers. Paul McLeod, Product Director of Storage at Supermicro. Iyer Venkatesan, who's the Solutions Marketing Manager, Intel Corporation. Steve Umbehocker, who's the founder and CEO of OSNexus Corporation. Jason Zimmerman, Senior Director of Technical Marketing at Seagate Technology. Anders Graham, who's the Director of Marketing and Business Development for SSDs at Kioxia. Thomas Paquette, who's the SVP and GM, Americas and EMEA for Graid Technology. Now let's jump into some presentations and to get a little bit more grounding on this topic. First, let's kick it off with Paul.
So, one of the impetus for having this session was really to talk about the different methods of doing storage, right? So Supermicro, as a hardware supplier, has to think about this in our portfolio, right? We have this huge portfolio. Some of these servers are designed for, specifically for compute. You get GPUs and things like that, they can be very dense compute. And other applications like storage, you'll want to have something that is very dense for storage. And so our group is focused on this very high density storage systems. One of the things that I think differentiates our product from the others is we have a system that is dual ported. So it's really designed for a scale up type architecture. And scale up, as you pointed out in your introduction, is really the entry point for storage, right? You're going to buy one system with the controller. It's going to be starting as scale up. For today's enterprise, high availability is one of the main concerns, and having dual ported, no single points of failure, fully redundant architecture in a 2U space really gives you that ability to have resiliency at that that single unit type purchase. From there, we go to our very large capacity storage servers using 3.5 inch. And those can be added to that dual port architecture and make a traditional scale up where I'm able to scale capacity by adding JBODs. Or they can be independent nodes and used for very large scale out architectures. Another area that we like to focus in is the emerging technology. So our ability to drive performance with the devices that are inside the system, whether that be a very high-speed networking card or be PCI Gen 5 next-generation EDSFF type storage devices. And one of the things that I look at for our customers is how the scale of the application that you're initially building and how fast does that grow. So those are some very high-level bullet points for the infrastructure that we're talking about here today. Supermicro is 100% software-defined. So we make this hardware. It has the physical infrastructure for our partners to build on. So if we're a drive vendor, you may have a dual-ported drive that we use in our system in that scale-up architecture. If you're a software vendor, you may have infrastructure that's dual-ported or able to do scale-out, right, with a virtualization of the storage infrastructure. So we really count on these partnerships with both the hardware technology and the software technology. So again, that's Supermicro in a nutshell, is optimized hardware configurations for storage.
No, it's great, and I think when you start to look at it, some of the core technology obviously is the processor in there as well. So why don't we kick it over to Iyer to really take a look at, what Intel role playing in this storage architecture.
Okay, hey, thanks. So from an Intel perspective, our customers can use either scale up or scale out, right? And we'll support them. What we look at more is what the customer's needs are, right? And what we find is that most of our customers, especially in the enterprise, they are going to use a scale out architecture, right? Because you can scale both performance and capacity. And it's also more what we call standards based, right? So whether you're using S3 or HDFS, NFS, that lends itself more, I think, to a scale-out architecture. But one of the things to look for is that when you're working with when a customer works with the storage vendor, right, we have a lot of configurations, right, and SKUs. So whatever they decide, whether it's scale-up or scale-out, right, they'll have to figure out what SKU best supports it for them, right? Because there are a lot of things that you can do based on the workload size, right? Based on performance requirements, based on how much you want to do backups. So there's a lot of storage functions that Xeon powers. But again, I think from our point of view, we support either or. It just kind of more depends on the use case and the workload that's being used by the customer.
Great, yeah, and I think that to me is, again, giving the choice to different organizations about what they do, but really focused on the workloads. We're going to bring Steve into this now and be able to help with, breaking down what OSNexus is bringing to the party as well.
Sure, yeah, thanks, Rob. OSNexus has been in the software-defined storage space for over a decade now, and some of the unique approaches that we've taken is to not really focus on just scale up or scale out. We do both. And that's because the application workloads really vary, and the cost savings that you get with a smaller scale up configuration can really matter in a big way to the bottom line. So we do both scale up and scale out. The other unique thing that we do is our Graid technology. And one of the reasons why we started OSNexus was to go and solve this management headache that organizations were having around having all these storage silos and 5 and 6 different products to go solve their storage needs. And so with the Graid tech, you can have multiple different clusters of storage in different data centers and manage it all as one. And those clusters can be a combination of scale up and scale out configurations all under one big umbrella. So that's what we do. And I think the last thing I wanted to mention is that we're really all about aggregating all the hardware together and deep integration with the hardware, and that's where we work very closely with Supermicro to make these systems work like a proprietary system in the sense that you have that deep integration with the hardware.
Yeah, and I think that to me is the key to all of this, where Supermicro is the glue that helps engineer with everybody a solution that's easy for the customer to really take on. And I think let's continue with Jason and really, hone in on how Seagate is playing a role in this as well.
Yeah, thanks, Rob, and thanks Supermicro for having us here today. Seagate's a name that's synonymous with hard drives for years, but I want to start off by talking about our NVMe product line that we have available today. It's a PCIe Gen 4 up to 15 terabyte and some decent performance in a U2 form factor. And we support the dual port, which goes with the Supermicro high availability solution for all your scale-up needs. Later this year, we will be adding PCIe Gen 5 with some pretty impressive performance numbers and capacities up to 30 terabyte. And that will also add the EDSFF E3S form factor. Over on the hard drive side, Seagate's really excited about some of the capacities coming up. The 30 terabyte capacity is coming out later this year with technology that we call Mosaic internally. Mosaic is a collection of technology that Seagate's been working on for a long time. It's really based on HAMR technology, which is heat assist magnetic recording. It's really been, a story of adding disks and finding space in hard drives for a number of years to increase capacity, because we are fighting the physical limits of being able to add more data inside of the same device and returning value to the customer. Mosaic and HAMR technology really is fighting a media problem more than anything. Media physical grain size needs to be smaller in order to record more material or more data onto the disks without having it be unreliable and decay over time. And so physical hardness is required, and when the media is that hard, it's really a challenge of being able then to write it. With heat assist, we're able to take light, transform it into heat, change the magnetic properties of the media in nanoseconds, and then write the media really with standard technology that Seagate's been using for years in perpendicular drives. Along with that, we have developed new readers and new sets of electronics that go along with it to be able to deliver some, good enough performance for the classification that hard drives fit in, which serves both needs on scale up and scale out solutions.
Yeah, and I got to say, I always love the little animation that you have for HAMR. It's just such a neat thing where you see it heat up and right across it, and I love that. I'm a geek for that kind of stuff. But let's pass it over to Anders and really Kioxia and what you're bringing to the party here too, because I think again this all goes to, it's about the data and where it lives and how you access it quickly.
Yeah, thanks, Rob. Anders Graham with Kioxia. Let me provide some real quick background on Kioxia. So we were formerly part of Toshiba, and the Toshiba spun out their memory group in 2019, renamed it Kioxia. So just real quick for the name, Kyoku means memory in Japanese, and Oxia means value in Greek. And so we're bringing value through memory, and our charter is really uplifting the world with memory. So some background on the name. We're one of the world leaders in flash memory and solid-state drive technology, operate a number of world-class fabs in Japan, and really a trusted supplier in SSDs. If we look at our products, we have both memory solutions and then also SSDs, which is really my focus. We've been working with Supermicro for a number of years and really gained a lot of traction with PCIe 4.0 SSDs, where Supermicro really drove as first to market on their end, through their server platforms. And then with PCIe 5.0, Kioxia was once again, first to market with their data center SSDs just recently in the last few years here. And those are gaining a lot of traction with Supermicro, both our CD8P single port, CM7 dual port drives for scale up versus scale out, which we'll get into in a little bit. And from a capacity perspective, we've seen a ton of traction on 30 terabyte, both in scale up and scale out, and so we'll talk more about why we're seeing that in each of the use cases.
No, I think that's great. I think again, it's about how you're servicing the customer, how this all works as a solution. And why don't we pass it over to Tom and really look at how Graid is bringing kind of a really interesting technology to the party as well.
Thanks, Rob. Appreciate it, and thanks Supermicro for having us here today. And you bring up a great point. We are absolutely enabling technology. As customers deploy hungrier and hungrier applications, and that hunger is for performance, servers are getting denser. NVMe drives are getting denser. We're in a position where these particular devices are storing mission-critical data, oftentimes. And what do you need to do with that data? You need to protect it. And you need to protect it at all costs. We've done something completely unique, and we like to say at Graid that we challenge the status quo on traditional RAID and what RAID and how RAID is defined. Our customers that are deploying these very dense servers with full of NVMe drives, typically you see that in AI, machine learning, right? And that is, any company today will call that mission critical, right? So we needed to come up with a solution, if you would, that not only protected that data at the different levels of RAID that our customers would expect, whether it's 0, 1, 5, 6, 10, depending what their application called for, but we needed to be able to find a way to do that without bottlenecking the performance of the server. In a nutshell, Graid, we go to market on an off-the-shelf GPU. So we didn't invent anything crazy to do this. We have industry-leading performance. One of the reasons Supermicro took us on as a partner is because of the way that we perform in these all NVMe environments. Our durability, that's what RAID is all about. RAID's all about durability. We can scale up inside of a single server up to 32 drives, and because of the relationship we have with the drives, and I'll explain that a little bit later on, we can scale up very elegantly and very linearly inside of that server. And people are typically buying NVMe drives today for some reason, and it's usually always performance. And anybody that buys anything in IT today is looking for a return on the investment. If you can't get all the performance out of your NVMe drive, are you getting a return on investment? Not really. So we're enabling you to get all that performance in those NVMe drives, and that's Graid in a nutshell.
Yeah, and I think again, it's as we go to the kind of Q&A section of this this panel, I think one of the things that's really interesting is there's different workloads that fit very well from a scale up or scale out perspective, and different use cases and different places people start, and sometimes you have a mixture of both. To put it mildly, having been on the storage side at a financial services company in a past life, I can tell you I had both in my environment in multiple data centers. I think what's really interesting is how you make it simple for them and how you bring the performance, the durability, availability, performance, all of these pieces to them, scalability, and help them with those use cases. But you know, what's also interesting is how they're all put together, and I love that Supermicro does this and helps work with you from all of you from an engineering perspective. Iyer, can you kind of give us an idea and tell us what the benefits of using the Xeon for storage workloads?
Sure. So I think that one of the main benefits that we have done is use this concept called offloading the CPU from what we would call administrative, sometimes even demanding tasks, so that it can focus on things like running queries or doing AI or other analytics. So with that, beginning with the 4th gen, we integrated in a number of accelerator engines, what we call it. And for storage, we have 3 specific ones. One is called the QAT, Quick Assist Technology, which does an offloading of the encryption and compression, decompression. And it's used by our customers for backup and recovery. The second one is the data streaming accelerator, or DSA. And that also offloads moving of the data between like the CPU and the memory, so that again, you can accelerate your reads and your writes. And again, all of this is to give the CPU headroom, right, to do really what we would consider it's like value add, functions. The third one is the volume management device storage engine, And what that does is that just gives you control of your SSDs without needing an additional adapter. On the other side, what we have here is the products for storage, right? So the first one is the virtual RAID on a chip. And the second one is the Intel Internet adapter. And then the third one is the IPU, Infrastructure Processing Unit. And I mean, they're all related because they just help you with the performance and reducing the bottlenecks. The IPU we would call out as well because that also does an offloading function as well. So it takes a lot of the stuff that infrastructure would do for infrastructure management, storage, reads and writes, and then it allows it to go. And then it works like with the CPU, but it's a separate separate unit for that. So yeah, I think that's the gist of it in terms of our strategy on offloading.
Yeah, and I think that makes so much sense, being able to offload and how you get the right silicon, I guess you could say, doing the right function and being able to be more scalable. Okay, now I want to bring Steve back into the conversation. Supermicro has been working with OSNexus on supporting its new high availability dual port system, which enables a great scale up NAS system. Since this is a storage architecture discussion, how does the customer use case affect OSNexus's recommendation of a scale up or a scale out architecture?
And that's a great question, Rob. When we're designing new systems for customers, we really start with their application workload and figure out what's the most cost-effective solution for that workload. And the latest generations of Supermicro systems, including this one right here, the 2U24 all NVMe unit, lets us put over 700 terabytes of all flash to work in a very compact footprint. So if we can fit the solution in something like that unit, we'll do that first. Scale out comes in for AI, ML, and a lot of the latest generation of workloads because they need the capacity and performance to scale linearly just by adding more and more units.
Yeah, I think that to me makes total sense, and I think it's a great way to actually frame that whole question. So let's throw it to Jason now. Seagate has recently announced Mosaic 3, which implemented heat-assisted magnetic recording, the hammer, in its disk drives, which allows higher areal densities and larger capacities. What is the roadmap of disk drives in the medium term, and which kinds of applications best utilize it?
Thanks for the question, Rob. Yeah, near term, we're looking at capacities that with Mosaic can double in the next 4 years, which really, it's been over a decade since the hard drive industry has been able to do that within the same box. And furthermore, right, like I mentioned earlier, we have been adding disks and cost meanwhile to be able to achieve those kind of capacities, which isn't the direction that we like to go. Areal density is true value in terms of return to the customer. And what we're seeing happen as the AI space develops too is a lot more applications that need the performance that Steve mentioned. And there is tremendous amount of spend happening today in that area. We do believe as AI develops, as new applications develop and things like that, obviously there's a great constraint on the marketplace in terms of power, in terms of space, and things like that. And we believe that the Mosaic technology continues to return to the customer within the same 3.5 traditional space. We're able to achieve under the same power footprint and same power footprint of the entire box, doubling the capacity over that period, which is really, there's a lot of AI hype right now around applications being developed and high performance, which is needed, absolutely. But we do believe that that is going to lead to continued growth in the storage market and where hard drives serve a purpose, and that will continue to grow as checkpoints continue to grow, as people see, data governance policies change with AI because they see a potential future value in data. And then not to mention the generative AI, which is a whole nother growth curve in terms of data generation in the marketplace that is right for scale out storage.
Yeah, I totally agree. I think, again, it's the right storage at the right cost, not to mention the sustainability aspect of that and doing more in that lower capacity there. Now, I want to bring Anders back into this because I think, again, it was just mentioned around the capacity of NVMe SSDs. have become very popular storage media for scale-out parallel file systems and scale-up high-performance file systems. Does Kioxia optimize SSDs for different storage workloads and architectures like scale-out versus dual port and scale-up?
Yeah, thank you for the question. So if we look at our CM7 SSD on the enterprise side, really the key differentiator for scale-up is, of course, the dual port functionality. So Kioxia has a long history with SAS SSDs, many generations of SAS controllers. And with that, we've taken those learnings and applied them to NVMe and now have the NVMe dual port options available. So those are primarily being used for scale up. There are some other differentiators as well, though. The enterprise class drives tend to have the highest performance. They also have a richer feature set, additional sector sizes, FIPS certification when that's required. But yeah, mostly it's for the scale up functionality that helps, or the dual port functionality that helps for scale up. When we look at scale out, the CD8P drives, they offer more of a cost optimized performance versus cost. So it's a good blend of performance versus cost. As I mentioned, single port, and then not quite as feature rich. But those are also very popular. And actually, when we look at the mix of the two different drives, you have probably roughly 80% of the petabytes is with the data center NVMe versus 20% on the enterprise side. And that's simply just because of the scale of these scale out deployments. They just pull more petabytes, generally speaking. However, the enterprise drives in the scale up architectures, they tend to be for very business critical applications, high performance, highly available. So they're very important, to Supermicro and their end customers, and of course to us as well. When we look at the different applications for scale up versus scale out, we're seeing the CM7s used, quite often as a back end for high density NAS configurations. NFS storage is becoming increasingly popular as a back end for virtual machines and containers, Kubernetes, other applications that require sort of highly available file shares. And then the issue that we have seen historically, which was touched on earlier, is that we're kind of blocked from a density deployment perspective on the scale up, right? But now, as mentioned, we can get up to 737 terabytes in a 2U box. So the 30 terabyte drive, it's really opening up a lot of doors. Switching gears to scale out, we're seeing a trend with scale out file systems for data analytics and AI. And the challenge there is that if you have multiple petabytes or hundreds of petabytes even in a deployment, it's really hard to do that in a scale up environment. So folks are moving to scale out, for those applications. We're also seeing hyper-converged scale out architectures continue to gain traction, so you can right size your storage versus your compute, your memory as you scale. And then the last point I want to make is that for object storage, like Ceph, MinIO, traditionally those have been the domain of hard drives. And really it's just because of the ultra low cost that you can get for hard drive deployment. But programmatically, it's easier to do sort of AI training on data that's stored in object. And so as folks want to increase their performance for object storage workloads, we're just starting to see a transition from hard drive to flash, and it's being enabled by that 30 terabyte capacity point.
Yeah, I think, again, the mix of how file systems versus object versus different use cases like AI versus, say, an ERP system, because people are still running those as well, or even email, which is sitting on site, or even just the file shares. So I think that, again, when you start to look at how this all comes together, it's really a key, and I think, again, we'd be remiss if we didn't talk about protecting it. So let's throw it back to Tom and Graid, because Graid has a unique approach to data protection using a GPU to accelerate the RAID algorithm, as you talked about earlier. And that helps to remove performance bottlenecks that come with traditional data protection implementations. This very fast performance makes it a good fit for data protection in a scale-up, all-flash design. How does Graid differentiate its implementation from the other host-based and server-based data protection designs?
Well, thanks, Rob. Great question, and that's one we answer a lot, as you might imagine, because we do something that is very, very unique in the industry, not only offering that data protection, but then accelerating data protection and accelerating the I/O inside of a server. So we set a baseline at the beginning saying that NVMe adoption is proliferating and at an accelerated rate. Servers are getting more and more dense, and people are deploying these for performance-hungry applications. At its basic level, Supreme RAID, Graid's flagship product, is a software-defined RAID data protection, RAID acceleration solution. What is it not? That's even an easier way to answer it. Supreme RAID is not a utility that sits alongside your applications next to the CPU and requires CPU cycles to perform its function. Now, parity, which is the basis of RAID, is one big math calculation, and that's how the data is protected. When we need to enact RAID, or if you have a failure, what parity can do, or what all this calculation involved in the rebuild of a drive, of a failed drive can do, it can bring the CPU to its knees because it's a very intensive operation. So by moving RAID off of the CPU and putting it on a very fast, massively parallel device like an Nvidia GPU, you can lose a drive, you can even lose 2 drives in a system depending on your RAID level, and you're not going to really impact performance that much at all. Comparatively, the other thing that we're not is we're not an ASIC-based hardware add-in card that needs to have the drives wired to it. How does that help at the end of the day? We don't need the data to pass through the GPU. As a matter of fact, we don't pass the data through the GPU. Supreme RAID sits on that GPU. That GPU has a peer-to-peer relationship with the drives. So what that enables us to do is start to scale up inside of a server very elegantly and deliver all the bandwidth that the drive manufacturers say that you're going to get, because we're not taking it through the GPU. We're sitting there, for lack of a better description, call us a traffic cop, and we're just going, put the data there, put the data there. It's a very, very simple, elegantly simple thing. From a scale-out perspective, Supreme RAID supports NVMe over Fabric as well. So we can elegantly scale out at line speed of the drives, where the only performance inhibitor that you might get would be the customer's network. One of the nice things about Supreme RAID, especially when you think about deploying it in a cluster with OSNexus over the top of the cluster, when you have a clustered environment and you're using the erasure coding in that environment to protect the drives, and a drive fails, the cluster goes haywire because it's trying to rebuild that drive from all the other nodes in the cluster. What happens if you lose 2 drives? Haywire would probably be an understatement to what happens to that cluster. What we provide is we provide local healing at a drive level. So if you have a multi-node cluster, you could literally lose a drive or 2 in any or even all of those machines in the cluster, and guess what? You're not going to impact performance. Very, very important, especially given the types of data that's resident on these clusters today. So, at the end of the day, what does all this really mean? So if you're deploying these wonderful servers from Supermicro with Intel CPUs, full of NVMe drives from either Seagate or from Kioxia, and you choose to protect it in a traditional method with some software RAID or some hardware add-in card, what have you done? Number one, you've done your users a disservice because you've initiated bottlenecking. What else have you done? You've taken something like machine learning, which is very intensive, and you've elongated the time that it's going to take to get that application, if you would, to production. And lastly, you've put the ROI on that technology out of reach by implementing that. So NVMe RAID is Graid Technology Supreme RAID.
Yeah, I think, again, you have to protect it, especially you brought up the whole AI and checkpointing and all of the data, because if you have to go back from a AI perspective and you have to go start all over again, you could be talking about days of actual processing and things of that nature, depending on how it goes. So I think, again, having that protection built in from the start is totally key. So right now, I want to throw it back to Paul to kind of, wrap things back together. You guys have, a massive portfolio of storage servers, one of the biggest in the industry. with all different kinds of capacities of flash and hard drives, it really looks to bring this architecture with the high availability dual port storage server has really brought a new direction for the customers to be able to go in. How do you help customers utilize both scale up and scale out designs?
That's a good question. And again, we are the biggest portfolio, right? That's one of the things that we get corrected a lot as PMs. Oh, we have one of the biggest. Well, we actually have the largest portfolio of hardware in the industry. There's no doubt about that. In terms of helping customers and right-sizing their storage implementation, it's really scale is the operative word there, because there's still many applications that are smaller scale and that might still need high availability. They might just need fast NVMe with some resiliency and some durability at a simple level. As we get to these customers that are doing AI and other things, they need something that may support very rapid growth, right? That's the real challenge for all of these software-defined architectures is, can they scale to the level of the application and to the customer's requirement? And more, that's been very challenging, right? When we see these AI clusters that have these incredibly large requirements, and those large requirements don't mean it's just throughput. It's IOP performant that they want to grow and be tens of millions of IOPS, at a push of a button. So these are challenges that our portfolio is particularly set up to support, whether it be a single node all-flash NVMe system or something like a smaller scale, redundantly connected, high availability system. Supermicro has the portfolio to deliver that good to the customer.
Yeah, and I think, again, it goes back to a lot of being able to engineer all of the parts and pieces together, have it really be forward-looking so that you have some investment protection as well. I mean, I've been able to hear a few other sessions because I'm sitting in them, and I can tell you that seems to be a key message from Supermicro and its partners is, hey, we're looking out and how you're able to solve a lot of these different problems. One thing that's not a problem, and I'll throw it back to Steve here, is there's a free trial. Why don't you tell us a little bit about that?
Yeah, OSNexus QuantaStore is available as a free trial. You can get it from our website. We've got a link to the page for that for this Open Storage Summit. And you can put QuantaStore on both scale-up and scale-out systems. And QuantaStore runs across the entire line of Supermicro hardware. So whatever you're getting, let us know. We'll help you get that trial edition software set up on whichever systems you've selected.
That's fantastic. So I want to thank you all. I mean, this is actually the biggest group that I think we'll have as part of the Storage Summit, the Supermicro Open Storage Summit. So thank you for coming on board and helping us break down scale out versus scale up. And thank you. Just take a note that our next session is going to be the new high performance computing optimized storage for HPC to AI on August 27th at 10 a.m. Pacific. Thank you for watching this episode of Scaling Up or Scaling Out, making the right storage architecture decision. Take care and stay tuned.